The meaning of differentiation is the process of finding the derivative of a function. The derivative represents the slope of the tangent line to the graph of the function at any given point, which tells us how the function is changing at that point. First, we have one of the most used rule, that is the power rule. If you have x to the power of n, the derivative is as the formula. You will multiply the n with the constant of x, then n will minus with 1. As you can see here, we will multiply the power with the constant of x, so the answer will be 3x squared plus 12x minus 7. Next, we have constant rule. If a function is just a constant, then its derivative is 0. Why? Because the constant doesn't change. Next, we have multiple constant rule. If you have a constant multiplied by a function, you can take the constant outside the derivative as the formula given. So the answer for this question is 4x minus 1. Now we will go through the sum rule. If you differentiate the sum or difference of function, you can differentiate each part separately. For example, this question, you can first differentiate x squared, then 4x to the power of 6. The fifth rule we have is product rule. If two functions are being multiplied, we use the product rule. For this question, we first separate them as u and v, then differentiate each of the part. As you can see here, for u we use the power rule, and for v we use the chain rule that I will explain later. After we then differentiate each of the part, we will use the formula of product rule to get the answer. We will substitute u v prime plus v u prime with the answer we get here. And this is the last answer. Next, we will go to quotient rule. Quotient rule is used when we divide two functions. For example, here, numerator as u, denominator as v. After we then differentiate u and v, we will substitute them into the quotient rule formula. And this is gonna be the last answer. Now I will explain the chain rule. The chain rule used when we have a composition of function. For the example question here, we're gonna separate them as dy and dx and differentiate each of them separately. After we then differentiate each of them, we will multiply dy with dx and differentiate them, so we're gonna get the last answer. So that's how we use the chain rule. Now let's take a look at trigonometric function. These have their own special derivative that you need to memorize. And here is the simple example. When we differentiate sine, it will be cos. In this question, we need to use a few rules so we can get the answer. And here is the last answer you're gonna get. Next up is exponent rule. In exponent rule, you just need to multiply exponent with the constant of x. Then that's it. We get the answer. The last rule we have here is logarithmic rule. In here, you just need to multiply 1 over x with the constant of x.
The question is find dy dx if y equal to tangent y minus 2x over 1 plus x. First, we differentiate tangent fx equal to sec squared 1 minus 2x over 1 plus x multiplied with d dx 1 over 1 minus 2x over 1 plus x. So we need to find d dx 1 minus 2x over 1 plus x. We use quotient rule to find it. Let u equal to 1 minus 2x, u prime equal to negative 2, v equal to 1 plus x, v prime equal to 1, and we substitute it. We get negative 2 minus 2x minus 2 plus 2x over 1 plus x squared. Then we get negative 3 over 1x, 1 plus x squared. Next, we substitute it to dy dx equal to sec squared 1 minus 2x over 1 plus x multiplied with negative 3 over 1 plus x squared. Then we get negative 3 over 1 plus 3 squared, x squared, 1 minus 2x over 1 plus x. Next, find dy dx if y equal to 2x cubed cos 3x squared. We use product rule. Let u equal to cos 3x, y equal to 2x cubed multiplied with u2, and dy du equal to u2 equal to 2u. Next, find du dx negative sine 3x multiplied with 3 equal to negative 3 sine 3x. Then we find u squared equal to 2u multiply with negative 3 sine 3x, and we get negative 6u sine 3x. We substitute it to dy dx equal to dy du multiply with du over dx. Cx squared multiply with u2 plus 2x cubed multiply with negative 6u sine 3x, we get 6x squared u squared minus 2 log 12x cubed 2 sine 3x. And the answer is 6x squared cos 3x squared minus 12x cubed cos 3x sine 3x. That's it.
To solve this question, we need to differentiate one by one, starting with differentiating ln to y. By using the formula of 1 over fx times f prime x, we can just substitute the value into 1 over 2y times 2 dy over dx. Then we can cancel out the 2's and it will be 1 over y times dy over dx. Next, differentiating y sine 2x. To solve this, we need to use the product rule, so we let u equals to y. Then u prime will be dy over dx. Then we let v equals to sine 2x. Then v prime will be cos 2x times 2. Then we just need to substitute the values into the formula of u v prime plus v u prime. Then it will be y cos 2x times 2 plus sine 2x times dy over dx. Then we can expand the brackets. It will be 2y cos 2x plus dy over dx times sine 2x. Next, we differentiate 2x squared. By using the power rule, we can get the answer of 4x. Then we differentiate 3, and it will be 0. Then we combine all of the differentiation that we have done into one equation. Then we move all of the parts that have dy dx into the left hand side of the equation, and the ones that don't have the dy dx to the right side of the equation. After that, we factorize the dy dx out of the equation. Lastly, we make dy dx as the subject. This will make the final answer as 4x minus 2y cos 2x over 1 over y plus sine 2x. That's all from me. Thank you.
I will be presenting about how to solve using differentials to approximate value. As we can see here, there is a decimal number in the question. What am I going to do first is define the function by excluding the decimal numbers. Before I can solve the fx, I have to identify the x, which is the nearest integer number for 7.99, which is 8. Next step, insert x or 8 into the function to get the answer for fx. The second step, I will need to find the change in x by taking the decimal number given and minus it with x. Third step is to find the prime fx or the derivative of fx. Using the original function I written on the first step, I have to rewrite the x by moving the third 3 as the power of 1 over 3 and then simultaneously move power of 1 over 3 and square in front at the same time, minus both with 1. And that's how to get prime fx. Next, I repeat the same process by inserting x or 8 into the function and obtain the answer. After finishing all the steps and gathering the information, I have to insert the answers into the linear approximation formula. Just rewrite the answers into the formula. Since the question demands the answer to be in 3 decimal places, I have to round the answer.